Hello everyone. Okay, so welcome again, and let's continue to discuss how to integrate a partial fraction decomposition that contains irreducible factors. Okay, so let's continue this discussion. Now I'm going to show you some complications that you can get. Okay, so this is a continuation of the previous video. So if you haven't watched the previous video, please make sure you watch the previous video of this video series. Alright, so if we want to integrate this rational function, I have already given you the decomposition. Trying to come up with the decomposition is not the primary purpose of this video. We will focus on integration rather than decomposition. So instead of integrating this rational function, we would like to integrate the decomposition because it's sort of easier. So okay, so you can integrate these terms in the decomposition separately. Okay, all right, so let's do this. Now speaking about integrating the first term, we can pull out this 12 out of the integral. Actually it's in the denominator, so we have to pull out 1 over 12. So you have to integrate 1 over x plus 3, and let's pull out this 12 as well. So it's 1 over 12 x minus 3 x square plus 3 integrate with respect to x, right? Perfect. Now we all know how to integrate the first term, first function here, 1 over x plus 3. So if you integrate 1 over x plus 3 with respect to x, you get natural log absolute value of x plus 3 minus 1 over 12. Now it's the question about integrating this term. Okay, so we have an irreducible factor in the denominator, so x square plus 3, you cannot factor it furthermore. So as we discussed in the previous video, what we do is we do integration by substitution, right? So we choose our substitute, choose our u to be x square plus 3. Now du over dx, the derivative of the substitute with respect to x is 2x. So this is just a term with x, and as we discussed in the previous video, this minus 3 that we have here is an obstacle, right? This minus 3. So to do the integration by substitution easily, what we do is we split this rational function. That means we divide each term in the numerator by denominator. So what we get is x over x square plus 3 minus 3 over x square plus 3. So I divided x minus 3, each term in x minus 3 by x square plus 3. And now we integrate. Okay, so let's make sure we are writing this clearly. So let's keep on writing this natural log part minus 1 over 12, and let's focus on what's going on here. So we want to integrate x over x square plus 3, and then we want to integrate minus 3 over x square plus 3. So let's integrate these two terms separately. So to integrate this term, as I said, we can use integration by substitution. So our u is x square plus 3. Du over dx is actually 2x. So that means dx is du over 2x, right? We can rewrite this one by switching the sides of dx and 2x. So dx is du over 2x. So let's use that. So if we use that, I'm only going to do this part. Okay, so yeah, I'm running out of space. So let's do it here. So how to integrate x over x square plus 3? All right, so we use the integration by substitution. So x square plus 3 is u, dx is du over 2x, and x cancel out. See, so what you have is 1 over 2 u to integrate with respect to u. So we can take half out. So integral of 1 over u is natural log u, absolute value of u. And u is x square plus 3. So half natural log x square plus 3 is always positive, so we can drop the absolute value sign. So that's what we get. Okay. All right. So we use integration by substitution. So let's replace that answer here. Okay. So still you don't see the complication, right? Because I didn't do that yet, because this problem is quite similar to what we learned in the previous video. So what we got is half natural log x square plus 3 by integrating this part. Okay, now still we want to integrate 3 over x square plus 3 with respect to x. All right, perfect. Now let's focus on integrating minus 3 over x square plus 3. Now I can take this 3 out the integral. So minus 3, we want to integrate 1 over x square plus 3. Now here we can use tangent inverse. So we discussed this. When we have irreducible factors, we use tangent inverse and the integration by substitution, right? So we learned the rule that if you have function like x square plus a square, 1 over x square plus a square to integrate with respect to x, the answer will be 1 over a tangent inverse x over a. Alright, so now what is a here? So a square is here, so a square is 3, so a is actually square root of 3, right? So be careful, okay? Alright, so the answer for that will be then 1 over 12 natural log. So that's the complication. I know it's a small thing, but I want to make sure that you grasp that correctly. So here 1/2 okay, why don't we write the final answer in a place where we have more space. So 1 over 12 natural log absolute value of x plus 3 minus 1 over 12, here half natural log x square plus 3, here minus what we get is negative 3, okay? So negative 3, so this negative is what we have here, 3 over 1 over a is 1 over square root 3, okay? Tangent inverse x over square root 3, okay? And close and plus c. So that's the final solution, okay? This is what you get after integration. So the first complication is getting the a here, deciding the value a with tangent inverse, okay? So there's one more case that we should study here, so be with me, okay? There's another complication. All right, so does that make sense? Again, a combination of integration by substitution and tangent inverse identity here to integrate a decomposition that contains irreducible factors, okay? Non-repeated irreducible factors. Okay, let's go on to the other case. So the complication here is, so let me give you a new problem. So we have to integrate, let's see, 1 over x minus 1 times 2x square plus 5, okay? So I will give you the decomposition. So the decomposition is 1 over 7 x minus 1 minus 2x plus 2 over 7 x 2x square plus 5. All right, okay, perfect. Now we know instead of integrating this rational function, we integrate this part, right? The right hand side. So let me do this fast. So if you integrate the first part, we know what we get is 1 over 7 natural log absolute value of x minus 1. So now we want to integrate negative 1 over 7 2x plus 2 over 2x square plus 5. Okay, so we use integration by substitution here first, right? So if you use integration by substitution, our u is going to be 2x square plus 5. Okay, we have a irreducible factor here. So du over dx is 4x, right? Okay, so we have this plus 2 as an obstacle. So as we did in the previous problem, we split the rational function. Okay, so let's split it. So we have 2x over 2x square plus 5 plus 2 over 2x square plus 5. We have to integrate with respect to x. Alright, so now what we do here is, let's integrate these two terms, functions, separately. So let's first integrate 2x over 2x square plus 5 and then later integrate 2 over 2x square plus 5. Okay, so here's what I'm going to do differently. First I'm going to integrate this one, the tangent inverse one, because that is where we have the complication. Okay, so let me show you the complication first and later do the trigonometric substitution. Not trigonometric substitution, sorry, integration by substitution. Okay, so if you want to integrate 2 over 2x square plus 5, okay, we know that we can take 2 out, so it's 1 over 2x square plus 5. But in the rule we only have 1 as the coefficient of x, right? Remember? So this will give you tangent inverse x over a 1a. Now how are we going to deal with the number 2 that we have here? Okay, so the coefficient is 2. Coefficient of x square is 2. How can we deal with that? So we want coefficient of x square to be 1. So what can we do? Well, factor that 2 out. So be careful. here. So let's factor that 2 out. Okay, so if we factor that 2 out, what we are gonna get is 2 over 2. So I took that 2 out of the fraction, so it will be on the denominator. So this 2 and this 2 cancel out. Okay, 1 over x square. So we took 2 out, but this is going to be 5 over 2, right? So that's the difference. We will get a fraction here, but still it's a number. So guess what is a now? So a square is 5 over 2, then a square is 5 over 2. So what do you think? A is square root of 5 over 2. So it's not the most beautiful answer that you get for a, but it is what it is. Okay, so the answer will be 1 over 7 natural log x minus 1 minus, we still didn't integrate this part, 2x over 2x square plus 5. So if you integrate this part, what we will get is 1 over a, so 1 over square root of 5 over 2 tangent inverse x over square root of 5 over 2 plus, okay, so we still didn't finish this integral. Okay, so that's the complication. What do you do when you have a coefficient other than 1 in front of x square, when you have to use this tangent rule? So you just factor it out from the denominator, and make sure you, when you factor it out, you divide what you had here by that number. When you pull out 2, this is going to be 5 over 2. Okay, all right, so let's use substitution to integrate this small integral. So negative 1 over 7 2x over 2x square plus 5. Okay, all right, so u is going to be 2x square plus 5, du over dx is going to be 4x, right? So if you use the substitution, this is 2x, this is u, dx is du over 4x, so x cancel out, 2 and 4 cancel out, and leave us with a 2 on the denominator, so we can take that 2 out, so it's going to be negative 1 over 14, 1 over u du. So it's negative 1 over 14 natural log absolute value of u. So u is 2x square plus 5. So natural log 2x square plus 5 will be always positive no matter what x value you have. So we can drop the absolute value. Alright, so we can write the full answer. So the full solution is negative 1 over 7 natural log x minus 1. From here negative 1 over 14 natural log 2x square plus 5. Okay. So let's see. Okay, so we have yes. So yeah, and we have to multiply by minus 1 over 7. Yes, don't forget that we have to multiply by minus 1 over 7. Okay, so this 1 over 7 was for everything. So 1 over 7, and here square root of 5 over 2 tangent inverse x over square root of 5 over 2. And yeah, this looks messy, right? Plus c. So that's the solution, a big one, but the idea is simple if you are careful with the complications. Okay, so the two complications here with the tangent inverse piece. Okay, but the big idea is when you have non-repeated irreducible factors, you use a combination of integration by substitution and that tangent inverse rule to finish the integration. Okay, so that's a one more important complication that we need to cover within this same case, which is how about, so all the problems in the previous video and this video, in all the problems we had a quadratic function like this on the denominator, but we didn't have the x term here. This is not a full quadratic function. A full quadratic function would have this bx part. How about if we have an irreducible factor like x square plus x plus 1? How are we going to work around that? Well, you will see in the next video. It's the same idea, but we have to be a little bit careful. Okay, there's a one complication. All right, so I'll catch you there. Thank you very much. Bye-bye.